In the case of hydrogen and the lithium, you can see that only one electrons will be present in the outermost shell. Is it right? When it loses the energy, again it comes back to the virginal state. There will be a transitions will be occurs that results in a difference of energy. We can easily calculate the radius and we can easily calculate the energy by using Bohr's theory. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Structure of Atom. Under that, we have studied about the dual behavior of the electromagnetic radiation. Under that, we have understood that how the electromagnetic radiation, they behave like a particle nature as well as the wave nature. In addition to that, we also discussed about the spectrum and the types of spectrum and the atomic spectrum also of the hydrogen atom also we have discussed. Today, in this session, let us move on to the next topic of this unit about the Bohr model of an atom. Let's see how the Bohr, he described the structure of an atom, and also I have given some of the postulate. Let's see what is the postulate for the Bohr model of an atom, and the last one, that is the limitations of Bohr model of an atom. Firstly, I'll go for the Bohr model of an atom. So the Niels Bohr in the year 1913 was first to explain the quantitatively the general features of the structure of the hydrogen atom and its spectrum. So he is the one who explained the structure of the hydrogen atom along with this spectrum. Okay, and also in addition to this, he also used the concept of Planck's quantum theory was proposed by the Planck. Okay, so he used the Planck's constant to describe the structure of the hydrogen atom. Along with that, he also explained the spectrum of the hydrogen atom. Now let us see how he described the structure of an atom. Let's see with the postulate. So in his first postulate, he says that every atom is surrounded by the number of shells. At the center, it always consists of positively charged particle. They are known as proton. So in an atom, always at the center, there is a positively charged particles will be there. They are known as protons. In addition to this, he gave another postulate when in an atom, electrons are always revolves around the nucleus with a certain definite circular path. Suppose imagine this is an atom. In an atom, there will be a nucleus at the center, and this is a nucleus. And he tells that the electrons are revolving around this nucleus in a definite circular path. So, these electrons are revolving in a definite circular path, and these circular paths are also known as orbits or the energy shells. They are known as orbit or the energy shell, where you can see that how the electrons are moving in a circular path with the orbits. Okay, they are known as orbits or the energy shell. In addition to this, he says that each orbit has a definite quantity of energy. Each orbit has a definite amount of energy, and it is indicated by the numbers are called as 1, 2 and 3, and it is also indicated with the letters called as K, L, M, N, where you can see that n is equal to 1 when it belongs to K shell, when n is equal to 2 it belongs to the L shell, when n is equal to 3 it belongs to M shell, and n is equal to 4 where it belongs to the N shell. Remember, each shells or the energy level, they have their own energy. It consists of certain amount of energy. So these are the three postulates was first given by the Niels Bohr. What does the first postulate tell us? The first postulate tell us that in an atom there will be always positively charged center will be there, and we call that positively charged center as a nucleus. And also he tell us that electrons are revolving in a circular path, and each circular path are known as orbits or the subshells. And each these shells or the orbit, they have their own certain amount of energy, and it is named as KLM, or the integers known as 1, 2, 3. In the next postulate, he tells us that only these orbits which permitted for the electron with the angular momentum and a whole number of multiple of h divided by 2 pi, where n is nothing but a 1, 2, 3. Remember here, he tells us that only the electrons are permitted to move along with the circular path with the angular moment, which is equal to L, which is equal to mvr. Okay, where mvr is equal to nh divided by 2 pi, where h is a Planck's constant and it is always equal to 6.626 into 10 power of minus 34 joules second. Whereas the n is the number of shell, where m is a mass of an electron and v is the velocity of the electron and r is a radius, where r is a radius. This is how he gave a relationship with the movement of the electron with the angular momentum. Remember, he tells us that only the electrons are permitted to move in a circular path in an orbital with the definite angular momentum. What will be the angular momentum? Which is equal to n into h divided by 2 pi. We know that L is nothing but a mvr, and if you substitute this value, you will get this relationship. In the next postulate, he tells that as long as electrons are present in a particular orbit, neither it absorbs or nor loses the energy. Therefore, it remains constant, energy remains constant, and these orbits are known as stationary orbits. Here, in the ground state, you can see that there is a nucleus will be there, followed by an electron. Is it right? Suppose if this electron, if it is gains the energy or if it is loses the energy remains constant. And such a state of an atoms are called as stationary state. They are known as stationary state, where the energy of an electron remains same. Okay? And it does not mean that electrons are in the stationary state, but just their energy is fixed. Suppose when the energy is supplied to the electron, it absorbs the energy only in the fixed amount as the quanta and jumps to the higher energy state away from the nucleus and is known as excited state. So when you provide some amount of energy to this electron, what will happen? This amount of energy will be absorbed by this electron and it gets excited to the next higher state. That is known as excited state. When the electrons are become excited, only when you provide the fixed quantity of quanta or the required quantity of energies, if you provide, it will be shift to the next state. That is known as excited state. In such cases, once it gains the energy, it will not retain in that higher excited state. Again, after losing that energy, it comes back to its original state and there will be a difference in energy will be caused. The difference in energy is obtained by delta E, which is equal to E2 minus E1, where E2 is nothing but the energy of an electron in the excited state minus E1 is the energy of electron in the ground state. This is how when you provide the definite quantity of energy to any electrons, it will get excited. Again, it comes back to its original state and causes a difference in energy. So, these are the 5 different postulates was given by the Niels Bohr. Next, let's see the achievement of the Bohr model by comparing with or by using this postulate, how I can easily do the numerical. Let's see now. Okay, the Bohr theory has explained the stability of an atom. As he explained that, according to the Bohr, we have understood that there will be a nucleus at the center, and there in an atom there is a positively charged center will be there, and he called that as a nucleus. And this nucleus is surrounded by the negatively charged particle. They are present in a circular path. They are known as electrons. When these electrons are moving in a circular path, each paths are known as orbits. They are known as what? Orbit, or the energy level, or the energy shells. And each shells will have their own definite quantity of energy. Okay? In the third postulate, he stated that only the electrons are permitted to move in the circular path with the angular momentum, that is L is equal to h divided by 2 pi. Is it right? In the fourth postulate, he says that suppose if the electron absorbs the energy, nor it emits the energy, but it keeps certain amount of energy with them. So such state of a substances or such state of an atom is known as stationary state. Suppose if you are giving the definite quantity of energy, the electrons will be moved towards the next higher state. So when it is excited to the next higher state, or when it is shifted to the next higher state, there will be certain transitions will be taking place. What will be the transition here? Transition means the movement of the electron from the ground state to the excited state. When it reaches to the excited state, when it loses the energy, again it comes back to the virginal state. There will be a transitions will be occurs that results in a difference of energy. In addition to this, he also explained the stability of an atom, and by using the Bohr theory, it helps us to calculate the energy of an electron in a hydrogen atom and one electron species. And the mathematical expression for this is energy of an electron, which is equal to minus 2.18 into 10 to the power minus 18 into z square divided by n. N is the number of shells and z is the atomic number, and minus 2.18 into 10 to the power minus 18, it is nothing but a Rydberg constant. Okay, by using this Bohr theory, we can also help us to calculate the radius of a Bohr orbit, and it is given by the relationship with the radius, that is Rn is equal to a to the power of a naught into n square divided by z, where Rn is the radius of the nth shell and z is the atomic radius, n is the number of shell. Here the a naught, which is nothing but a radius of the first Bohr orbit, and it is always equal to the 52 picometer, and it is constant. Now, let's see with the limitations of the Bohr theory. Later, we'll solve the numerical by using these two formula. Then we will understand how to calculate the numericals. When we move on to the limitations of this Bohr model, this theory cannot explain the atomic spectra of an atom containing more than one electron or multi-electron. So, this kind of explanation of the atomic spectra, it is only applicable to the certain elements such as hydrogen, lithium, and also in the case of hydrogen and the lithium, you can see that only one electrons will be present in the outermost shell. Is it right? So only one electron will be present in the outermost shell, and this theory is applicable to the only to the certain atom where it consists of only one electron in the outermost shell. Whereas for the rest of the element which consists of many number of electrons in the outermost shell, this theory cannot be applied. And Bohr theory has failed to explain the structure of spectral line. It has failed to explain how the spectral lines will be there, and the structure it is not explained properly, and it could not explain the Zeeman effect and the Shark effect. And the Bohr theory has failed to explain the ability of an atom to form it by a chemical compound. When the electrons gains the energy or when the electron cell loses energy, how does it forms a bond with any other compound to form a chemical bond? It is not completely explained by this Bohr theory, and it was not accordance with the Heisenberg uncertainty principle. So these are the 4 different limitations of the Bohr atomic model. Now let's solve the numerical. How to do with this? Let's see now. What are the frequency and the wavelength of the photon emitted during the transition from n is equal to 5 to the n is equal to 2 state in the hydrogen atom? So first, write a hydrogen. This is a nucleus. This is n is equal to 1, n is equal to 2, n is equal to 3, and again n is equal to 4, and last state is n is equal to 5. Is it right? And in the hydrogen we know that only 1 electrons will be there. So this is how we usually name with a KLMN shell. Now we need to understand that this electron which is present in the ground state, it will be excited to the 5th state, and the electrons are present in the second shell, that is on this position. The electrons are present in the n is equal to second position, that is in the L shell it is there, and it is excited to the 5th shell. So we need to calculate the differences with this shell. So first, we know that they have given the transitions of the 2 states, so that mu is equal to delta E divided by H. In order to know the transition between the 2 energy level, that can be obtained by delta E is equal to minus 2.18 into 10 to the power of 18 into 1 divided by n1 square minus n2 square. It is minus 2.18 into 10 to the power of minus 18 into 1 divided by n1 is a 2 square minus it is 5 square, which is equal to minus 2.18 into 10 to the power of minus 18 divided by 1 divided by 4 divided by 1 divided by 25, and the answer will be equal to 4.578 into 10 to the power of minus 19 joules. So now we got the values of the delta E, that is a change in the energy. After knowing the delta E, now we have substitute to the above equation. So it will become 4.578 into 10 to the power of minus 19 divided by, what is the H value? It is 6.626 into 10 to the power of minus 34. So how much you will get here? So you will get 6.91 into 10 to the power of 14 hertz. 10 to the power of 14 hertz. Now we need to calculate the wavelength of the photon. That is obtained by lambda is equal to wavelength we need to calculate. Now we got the frequency, that is a mu. Then we need to calculate the wavelength, that is obtained by lambda is equal to C divided by V. What is the C value here? So 3 into 10 to the power of 8 divided by, what is the V value? 6.91 into 10 to the power of 14. If you divide these two, you will get 434 into 10 to the power of minus 9 meter. Or you can write directly as 434 nanometer. 434 nanometer, because it is a 10 to the power of 9, we can convert it into nanometer. This is how They have not given the frequency, but we know the difference in the energy. First, we need to calculate the difference in energy. Later, after obtaining the difference in energy, substitute the above equation. Then you will get the values of the mu to calculate the wavelength. Okay, that is lambda. You will get 434 nanometer. This is how we can easily solve the numericals. Next, calculate the energy associated with the first orbit of the helium and what is the radius of the orbital. Here they have given the helium. We need to calculate the energy. We know that En, which is equal to minus 2.18 into 10 to the power of minus 18 into Z square divided by N square. So here the atomic number of the helium is 4 and N, which is in the first orbital. Is it right? So it is 2.18 into 10 to the power of minus 18 into 4 square divided by 1 square. So how much you will get here? 8.72 into 10 to the power of, so it is minus 18. 10 to the power of minus 18, 4 square will be become 4 into 4, 16. It is a 8.72 into 10 to the power of 18 joules. 10 to the power of 18 joules. After knowing this, the energy of the helium atom, we need to calculate the radius. Radius of the nth shell can be obtained by A0 into Z, A0 into N square divided by Z. So what is the A0 value here? That is nothing but a Bohr constant and it is always equal to the 52 nanometer and it can be converted into 0.052 meter into what is N here? 1 square divided by what is Z here? That is 2. So you will get 52.9 it is. So directly you can write it as a 52.9 can be written as directly as 53. So if you subtract these two 0.0552.9 into 1 square divided by 2, you will get 0.02645 nanometer. 0.02645 nanometer. This is how we can easily calculate the radius and we can easily calculate the energy by using Bohr's theory. Hope you all understood. Here I have taken the values of the A0 as a first Bohr's constant, that is 53, or you can use 52.9 directly, and it is expressed in pi picometer or you can express in a nanometer itself. Hope you all understood that how I have solved with this by calculating the energy as well as the radius. In the next session we are going to deal with the dual behavior of the matter. And by this I like to say that for the examination point of view, the Bohr atomic theory for the hydrogen atom, it is very important. Have a look with all the postulate. In the exam they can ask you to write any 3 or 4 postulate along with the numerical. Hope you all understood and we will meet you in the next session. Till that, take care. Thank you.